capacitance is the ability to store the charge in two plates is called capacitance. So this charge is represented by Q, okay, that is proportional to the voltage, or we can say potential difference applied to that particular circuit, okay. So you can represent this charge is directly proportional to V, okay. The charge Q is directly proportional to V, or we can represent this with equality sign by represented one constant right here, okay. So this C is a constant which is represented as capacitance, okay. So Q is C into V, or we can calculate this capacitance C is equal to Q upon V, okay, where Q is the charge stored inside these two parallel plates, okay, and V is the voltage, or we can say potential applied to the circuit, okay. So unit of this capacitance is farad, or we can represent it as coulombs per volt. These are two parallel plates, okay, these are two parallel plates, these are represented right here. When you apply some voltage V across this particular circuit, okay, some current will flow through this particular circuit, okay, and these parallel plates, okay, store some energy or store some charge right here, okay, and this particular charge which is stored right here, okay, that is represented as capacitance. So this the total energy required to transfer q coulombs of charge, resulting in a final potential of V volt between the two plates. How we can find out this work done? Work done can be find out by 1 by 2 into potential applied across this particular circuit multiplied by the charge storage, or we can say the transfer of charge from one plate to the another. So this charge is moving from one plate to another, okay. You can represent this with 1 by 2 into V into Q, okay, V into Q, okay. So you can represent this charge. We have seen how you can write the charge. Q is equal to C into V. In the previous case, you can see right here, this Q is equal to C into V, and we will put this equation right here in the work done formula. So this Q is equal to C into V, and we multiply these terms, and we will find out the total work done is equal to 1 by 2 into CV square joules, okay. So in parallel plates, the capacitor C is directly proportional to A, and we can represent this with the proportionality constant, okay, and you can write the area right here. Area is equal to 1 upon D, okay, and we change this proportionality constant with epsilon naught, okay. So epsilon naught is equal to A upon D, okay. So you can write this equation finally as C is equal to epsilon naught A by D, where A is the area, okay, and D is the distance, okay. So what is the distance? Distance is in between these two parallel plates, okay. This is D right here. So when this charge is moving from one plate to the another, okay, so distance is in between these two plates. These components, basic components we are using in this passive element circuit, okay. A network containing circuit element without any source, energy source, is called a passive element network. Active network containing energy source together with the circuit element. So what are those? When we connect some voltage source right here, let's suppose that this is a voltage source, you can connect, and across this we connecting different components. Okay, so this is your active network. Okay. What is the constant value? This resistance remain the constant. Okay, this resistance remain the constant. And when we discuss about the inductor, okay, so V is equal to L di by dt. Okay, this I is changing but L remain the constant. Okay, when we discuss about the capacitor, okay, so capacitor voltage 1 by C under this integration of I dt. So this capacitor remain the constant. Ideal voltage source. How you can represent a voltage source? You can represent a voltage source by plus and minus symbol. This is your voltage symbol. Okay. So this is ideal voltage source. When we discuss the ideal voltage source, that means there is no loss in the voltage source. Okay. So this plus and minus sign represent it is a positive, okay, and it is a negative. Okay, and you can connect this particular voltage source to any circuit and current will flow through across that particular circuit. So right here we are providing some voltage source. There is no fluctuation, okay, in the output voltage. There is no fluctuation in the output voltage, so it remain the constant, no variation. Let's suppose that at this T1 time it is 3 volt, at T2 time it remain the 3 volt. There is no fluctuation in the output, so it is ideal voltage source. Means, what do you mean by ideal? Ideal means that will perform accurately 100%. Okay, 100% accurately that will perform, that will be perfect. Okay, there is at particular time T1 to Tn, this particular circuit and these components will heat up. Okay, will heat up and they produce some losses. Okay, there are some internal resistance also. Okay, there are some opposition also. In case of resistance, you can represent this current source by this arrow symbol. Okay, this is your current this current source, and you can represent this current source by this I of t. Clear? And you can also represent this current source with this symbol. Okay, you can connect this current source using this notation. Okay, so ideal means there is no change in the current. Okay, it remain the same when it start and when it stop, it remain the same. That is ideal, that is perfect. Okay, no change in the output. So you can see right here VI characteristics of this ideal current source. Okay, at every voltage this current remains same. Okay, but when we discuss about the practical current source, you can see at voltage level V1 it is, let's suppose that 1 ampere, but at voltage level V2 it is decreasing, let's suppose 0.8 ampere. Okay, so it is decreasing. So that means when you connect any circuit, okay, its value is going to change by different factors. Like there are some noises, there are some internal resistance also, there are some heat dissipation also. So with the help of these internal factors, our current source will not give proper output. Okay, so that will be called as a practical current source.